Hello humans, my name is Professor Leach, and today we're going to look at square roots as 1/2 exponents. And then we're going to expand on this idea. So we start off with square roots as 1/2 exponents because it takes the thing that's familiar, something like the square root of 9, a notation that we're familiar with, and a concept that we're familiar with, and say the square root of 9 is equal to 3. And my claim is that we're replacing the square root part with an exponent of 1/2. And I'm going to write it on single line syntax because I need to practice my use of parentheses. So these are all things that we know. And we know why these things are the way they are. The square root of 9 is equal to 3 because 3 squared is equal to 9. So that's what that square root symbol means. The symbol itself is called a radical. So with square roots, we're using radical notation. When we write things as roots, we're dealing with radical notation. That's why today's introduction was me talking about so many radical ideas. Like, humans have value. Radical notion. We're talking about radical notation. This symbol is a radical symbol. We'll just call it a radical. The stuff inside is called the radicand. The stuff inside is called the radicand. And this radical symbol is specifically a square root. And we don't have to index a square root. So we need to introduce other kinds of radicals. So square roots are 1/2 exponents. Cube roots are 1/3 exponents. And here I'm just going to replace my 2's with 3's. So to write a cube root, we write a radical, but in the little corner of the radical, we write a 3. And that is the index of the radical. So that 3 is the index of the radical. Some cube roots that we might know is the cube root of 8 is equal to 2, because 2 to the 3rd power is 8. So the cube root of 8 is 2, since 2 to the 3rd is 8. So we would read this as the cube root of 8 So we'll read that as the cube root of 8. The cube root of 8 is 2, since 2 to the 3rd power is 8. So there is the cube root of 8 written in radical notation. But cube roots are also 1/3 exponents. So we could also write this same information as, so the cube root of 8 is equal to 8 to the 1/3 power, which is 2. So we can contain the same information by writing the cube root of 8 in radical notation, or 8 to the 1/3 in exponential notation. So we've got radical notation, and we have equivalent exponential notation. Our calculator understands both of these notations. So if I want to do the cube root of 8, I just have to find where it is. So under math, we can see that one of the selections is cube roots. So I can say the cube root of 8 is 2. I can also use exponent notation, 8 to the parentheses 1 divided by 3, 2. I need parentheses around the exponent because I want to take the 1 divided by the 3 first and then raise 8 to that power. If I just type 8 to the 1 over 3, the order of operation says raise 8 to the first power, then divide the result by 3, and we just end up with 8/3. We just end up with 8/3. That's not what we want. That's why we need the parentheses. Any questions? So, radical notation, exponential notation, both for the same thing. Cube roots are 1/3 exponents. One of the things that we want to do is to make sure this fits with what we already understand about exponents. Does this fit with some of the things that we know about exponents? So a question becomes, do these radical exponents fit with the rules we already have for exponents? So this is an important thing. I mean, because here I'm introducing these radicals and saying they're fraction exponents. And you're like, oh, dude, how do we count to 1/3? I'm like, well, don't call me dude. And second of all, don't worry about it. It's just a thing. And the answer is, of course they do. It would be terrible otherwise. And we'd have to find another way to say this stuff. So absolutely. Let's see that in action. We know that the cube root of 8 is 2. We know that 8 is a 1/3 power. So let's remember that if we take x squared and raise it to the 3rd power, our shortcut for doing this is we multiply the exponents. So that's a shortcut, multiply the exponents. It's a shortcut to multiply the exponents. We think about what this means. X squared to the 3rd means copy of x squared times the x squared times the x squared. That's 6 of them, 6 x's. And so we get x to the 6th. So if I have a cube root of x and I cube it, if I think about, we know that this will, the cube root of x is the inverse of a cube, but it should fit with our exponent rules as well. This means take x to the 1/3 power and raise that to the 3rd power. And 1/3 times 3 is equal to 1. So we multiply the exponents. When we raise an exponential expression to an exponent, we multiply the exponents. It looks bad with all these exponents around. Let me write it in, I don't know why I'm quarantining all of these things in this extra box. Cube root of x to the 3rd will be x to the 1/3 to the 3rd, x to the 1/3 times 3, x to the 1. So yeah, these radical exponents fit with the rules that we already have for exponents. Otherwise, we'd have to do something else. Any questions? So square roots are 1/2 exponents. Cube roots are 1/3 exponents. The big idea here is, and the reason that we have to have these words for things is that the big idea here is that the index is the denominator. There's a nice little summary. The index is the denominator of the exponent. That's how we take the square roots are 1/2 exponents and generalize it. The index is the denominator of the exponent, the index of the radical. Dang it, I wanted to say that. Index of the radical is the denominator of the exponent. The index of the radical is the denominator of the exponent. The index of the radical is the denominator of the exponents. So now we can expand this idea. Fourth roots are 1/4 exponents. So if we take 16, or the fourth root of 16 will be 16 to the 1/4. We can check that on our calculating machine. If we take 16 and raise it to the 1/4 power, we get 2. If we want a fourth root, in the math button, after we get to square roots and cube roots, it's just like, oh, generic root. That means we have to put the 4 in first. So I have to put 4 and then go to the math menu for the generic root. So that's fourth root of 16 is 2. So we type the index first. So that's kind of unfortunate because it makes very bad looking expressions on your calculating machine. I think it does it differently if you turn the math print on. So I think it's different, but you still have to press 4. Yeah, fourth root of 16. I don't know if you can press this first. I can't remember. Yeah, if you push this in, then if you have the pretty print on or the math print on, then you can bring a generic looking radical onto your screen. But the important thing is that the index of the radical is the denominator of the exponent. The index of the radical is the denominator of the exponent. So fourth roots are 1/4 exponents. Fifth roots are 1/5 exponents. They don't have names anymore after this. It's square and cube and then fourth, fifth, sixth, and so on. Fifth root of 32 is 32 to the 1/5 power. So when you see an index in your radical, you say the index root. So fifth root of 32. It's important to pronounce things correctly because we usually see the radical symbol and we're first introduced to it as a square root. So we don't want to say square root unless the index is 2 or there's not, that which isn't written. We want to make sure that we pronounce this the fifth root. Of 32. That is the fifth root. Fourth root. We could also say third root and second root, but that's weird. We say cube and square for those. But you want to make sure that you read the symbols correctly. Pronounce that the 5th root of 32, the 4th root of 16. The important thing to recognize is that the index of the radical is the denominator of the exponent. What this means is that radicals can now show up in our expressions. Let's talk about radicals showing up in our expressions. Let's suppose that we have an expression that says the cube root of 2x minus 5. So this is how we group things in a radical. The radical symbol will act as a grouping symbol by extending the bar over the radicand. So the radical acts as a grouping symbol by extending that horizontal bar over the radicand. Radical works as a grouping symbol by extending the horizontal bar over the radicand. The stuff that's supposed to be inside it. So when I write this symbol, cube root of 2x minus 5, and the 2x minus 5 is all under the radical symbol, this means the 2x minus 5 is being raised to the 1/3. This is one way that we can use the radical as a grouping symbol. Sometimes I've seen some people put a little line at the end of it to say, hey, all this stuff is inside. This is an indication that we know that this is terrible notation, this radical symbol notation. Just extend the bar. It's like, well, what if we just want the cube root of the 2x and then subtract the 5 afterwards? Then we're just like, I'll just extend the bar over the cube root of the 2x and then put the minus 5 on the outside. And it looks terrible, because did you mean to extend the bar? And, or is it this, or is it just around the 2x? One way we can get around that is to use a radical, which is itself a grouping symbol, and then to clarify with parentheses. Including parentheses in the right place only adds clarity. Because we want to make sure that when we read this, we see that the order of things to do is first, we're going to multiply by 2, then second, we're going to subtract 5, and then third, we'll raise to the 1/3 power, or do a cube root. As opposed to an expression that looks like this, cube root of 2x minus 5. Here, the radical extends only over the 2x, and so this one means only the 2x is being raised to the 1/3 power. If we want to write this in with parentheses, because we want to increase our clarity, we could put the 2x in parentheses and really indicate that only the 2x is being raised to the 1/3 power, and then we're subtracting 5. we want to make sure it's clear that only the 2x is the radicand. We can use parentheses to emphasize that and fraction exponents to emphasize that as well. Any questions? Another good way to write this with radicals is to put the radical at the end, because the radical, we can extend the groupings of the radical by extending the bar of the radical, which is not a good idea. Maybe it was fine when people wrote things more carefully. But another way to do this is say, you know what, I'm going to put the 5 in front, then there's no way to confuse it with what's going on. There's no way to confuse the fact that the order of operations here should be first multiplied by 2 and second raised to the 1/3 power. And then finally subtract 5. It's not quite as bad if we have a coefficient. So for example, if I have the expression 2 in front of a cube root of x, putting a constant in front, as long as it doesn't look like it's jamming up into the index, then this is 2 times the cube root of x. And so we want to read the order of operations here. First, we subtract the 5 because that's in a grouping symbol. So this is also equal to 2 times x minus 5 to the 1/3 power. And now we've got a far superior expression because it's much easier to see that first we subtract 5, second we raise to the 1/3 power because exponents before multiplication unless parentheses, and third we multiply by 2. This is part of the reason that I'm not really a fan of radical notation, because when we're writing things out, we have to write this 3 kind of small and up. And if I have something like 3 times the square root, if I have, for example, 3 times the square root of x minus 5, if we're not careful about how we write this, maybe the 3 gets jammed up into the index and we think it's a cube root of x minus 5. So here, this raises the question. Make sure to distinguish between your coefficient and your index, because for square roots, the index is blank. The index is blank, it's a square root. Make sure be sure that we distinguish the coefficient and the index. One way we could do that is to write x minus 5 to the 1/2 power. Now it's very clear that 3 is being multiplied by the 1/2 power of x minus 5. Any questions? Comments? Snide remarks? So we want to make sure that we distinguish between these things, because what if I have right after this cube roots of x minus 5? Now the 3 is the index, and the index of the denominator sorry, the index of the radical is the denominator of the exponent. So we got to make sure that we distinguish between the coefficient and the index. This is especially bad if things aren't being squared. Or sorry, if things aren't just numbers. Like if I have a power of x out in front, is this 3 the exponent of the 3 or the index of the radical? But if I say, oh, what I meant by this is now it's clear that the 3 is the exponent of the x and not the index of the radical. But maybe I've written x times the cube roots of x minus 5, and we have the same issue. So we can fix this by saying this is x times an x minus 5 to the 1/3 power. So now we've made it clear because the index of the radical is the denominator of the exponents. Writing things in a single line with fraction exponents is not perfect, but it gets away from some, but mainly that's because we have to learn how to properly use our parentheses. Writing things in radical notation requires too much on the positioning of the exponent and the positioning of the index. And you combine that with the general sloppiness of our penmanship, and you can get some kind of confusing looking expressions. So it's really important to be able to translate between the two so that if you need to, you can clarify what you are trying to say. You could also clarify what you're trying to say, as usual, by just dropping some parentheses. I mean this. Now it's very clear that that 3 is the index of the radical and not the exponent on the x. And you could do the same thing up here by writing x cubed times the square root of x minus 5. Parentheses are always useful for clarifying what you're trying to say. Any questions? This was a lot and it was kind of rambly but the core thing to walk away from here, the core thing that you walk away from today with is that the index of the radical is the denominator of the exponent. Now, if you want to go into the book, remember the MyLab and Mastering the textbook is running parallel to what we're doing, but not necessarily matching everything up. We don't get into radicals in the book until like the last chapter. And I'm talking about radicals now because I care about talking about exponents, and radicals are a type of exponent. That's why we're doing this now. Because we're trying to learn to read. We're not trying to learn 8 simple tricks to crush your next algebra test. Because that's what gets us into these kinds of situations where people hate math in the first place. We just never taught them how to read. Apart from that, I believe that's it. I'm done. Email this to your grandma and I'll see you some other time.